So, hi everyone, I am Upasana Mishra and welcome to my educational channel, The Funda. So, today we are going to learn about motion in a plane. So, this is a chapter in physics. So, before learning about motion in a plane, we have to define what is a vector quantity. Okay, so a vector quantity is a quantity that has both magnitude and direction and follows the laws of vector algebra. So, the example of vector quantity are force, displacement, acceleration, etc. So, in case of displacement, as we had discussed in the last chapter, we have to define the direction of the displacement. Without defining the direction, the complete information is not given about displacement. Okay. So, in case of force also, we have to define the direction. In case of acceleration also. But for example, uh, mass, say mass. So, if I say the mass of the potatoes is 3 kgs, so we don't have to define any direction in case of mass or in case of temperature. So those quantities are known as scalar quantities. Okay, so vector quantities means it has both magnitude and direction, and scalar quantities doesn't have direction. Another thing that is written is that it follows the laws of vector algebra. Okay, here you can see it follows the laws of vector algebra. So, what is vector algebra? That question might arise in your mind. So, uh, you must have learnt normal algebra in your kindergarten and uh, when you were a child. So, we know that if I add 3 kg plus 3 kg, so what will be the answer? Obviously, we will tell 3 plus 3, that is 6 kgs. Okay, simple. So what you did is that you just added the numbers, that is 3 plus 3. So in case of scalar quantities, because mass is a scalar quantity, so we can easily add those quantities like we add two numbers. But in case of vector quantities, we cannot do that. Means in means the funny and the interesting thing is that in normal algebra that you have learned in your childhood, 5 plus 5 is 10. But in vector algebra, 5 plus 5 may not be 10. So how is that? Let us understand. So if let me give you a practical situation, then I can tell that why the laws of vector algebra are different from the laws of normal algebra. So for example, same. For example, say there is a rock here, okay, and two people, one is standing here and another person is standing here, okay, and they start pushing the rock, okay. So this person is applying 3 Newton force, okay. The means the unit of force is Newton. So just say it is 3 Newton. Just you can ignore the unit. Just say 3. So this person is applying 3 Newton force here, and this person is also applying the same 3 Newton force in the opposite direction. So if two people are applying 3 Newton force in opposite direction to the same rock, then that rock will never move. That you can say that, because if I am pushing from this side with same force and another person is pushing from this side with the same force, then the rock will stay in the same position. It will not move. So what is the net amount of force that is applied to the rock? Here, as you can see that one person is pushing from this direction, another person is pushing from this direction. So obviously the net effect of those two forces, those two, that is 3 and 3, those two, say one is pushing with some with a force 3 and another is pushing with a force 3, so the net effect here is 0. Okay, so the net effect is 0. So if you use normal algebra that you have learned in your childhood, that okay, so 3, if I say that 3 Newton plus 3 Newton is 6 Newton, then this will be completely wrong, because here the net amount of force or net amount of these two quantities, that is 3 Newton and 3 Newton, is not 6, it is 0, because both have opposite direction. So in vector algebra, as direction is involved, as we are also giving emphasis to direction, that is why in vector algebra we cannot add those numbers as we do in scalar quantities. Like 3 kg plus 3 kg, we will directly say 6 kgs. But 3 Newton plus 3 Newton, or 3 meter towards the west and 3 meter towards the north, this is not 6. Okay. So two vector quantities, we cannot add using normal algebra, that is the adding of numbers. That we cannot use in case of vector quantities. So what we are going to use, how we are going to add those quantities. See here you have added 3 Newton and 3 Newton and you got 0. Okay. So how we are going to add those now, add those vector quantities, that we are going to learn in this class only and in subsequent classes. So vector quantities are represented by like this. If I say A is a vector quantity, then I will write like this. Means I will give an arrow in the upper side of A, just to show that A is a vector quantity. Another way is that it is written in bold. Okay, like this. If I do bold A, then that is also a vector quantity. But while writing, it is very difficult to do means make the letters bold. So while writing, you may use this convention. But in books and when you will read your question paper and all that, so in that case, it may be written like this. So don't be confused. It also represents a vector quantity. Okay. So how are we going to graphically represent a vector quantity? That is very simple. So what we will do is that if we will draw an arrow, say it is straight line, we will draw an arrow. Okay. So this is the representation of a vector quantity. So the length of this arrow, that is this length of this arrow, this shows the magnitude of the vector quantity. And the direction in which the arrow is pointing shows us the direction of the vector quantity. For example, if I say I draw an arrow like this, then this is the graphical representation of a vector quantity. Sorry, this is the graphical representation of a vector quantity, and the length of this arrow tells us about the magnitude of that vector. If the length is suppose 3 centimeter, and if I write 1 centimeter is equal to 1 Newton in physics or anything, if I write, then 3 centimeter means 3 Newton. That means the magnitude of this vector quantity that I am defining is 3 Newton, and the direction is in this direction. Okay, is pointing in this direction. Here I have shown you the direction. So like this, graphically we can draw the vector quantities. Okay. So if I draw two arrows like this to show vector quantity. So this is an arrow, and just parallel to it I am drawing another arrow. Okay. The length is same. So as you can see in these two arrows, assume it is straight. In these two arrows, they are pointing to the same direction. Okay, here the direction is like this, same. And also the length of both these arrows is same. Okay, say this one is 3 centimeter this arrow has also a length of 3 centimeter, and the direction in which they are pointing is the same. Say this one is north, south, east. So this is northeast. So both are pointing to the northeast direction. So these two arrows are equal vectors because their magnitude and direction are same. So what we can do is that if we are given a vector quantity like this, okay, so let's say this is a vector quantity. So what we can do is that we can parallelly shift this vector quantity. This arrow we can parallelly shift. Okay, so if I parallelly shift this arrow, then it will be here. And both these arrows represent the same vector quantity. Okay, so when we will be discussing about the sum of vector quantities, then I will parallelly shift the vector quantity or that arrow, and by parallelly shifting that arrow, the vector quantity remains the same. Okay, it doesn't change. But if I rotate this arrow, if I make this arrow like this, means like this, if I make this arrow, then this is not the same vector quantities. These are two different vector quantities because this arrow is pointing towards another direction, say this direction, and this upper arrow is pointing to another direction. Okay, so both these arrows are pointing in different directions. But this arrow, like the first, say A and B, these two arrows are pointing in the same direction. So these two are the same vector quantities. So different ways you can means like this vector quantity and this vector quantity. These are same direction because they are pointing to the same direction, but their magnitude is different. As you can see, the length of the arrow. Similarly, this, say if I say this and these two arrows, that is two vector quantities, they have different direction. As you can see, they are pointing to different direction, and also they have different magnitude because the length of these two arrows is different, as you can clearly see. So this is simple, only you have to just graphically represent like this. Okay, it's very simple concept. So what will happen if I multiply a scalar quantity like a number to a vector? Okay, so if I say that this arrow represents a vector quantity, that is A. Okay, this arrow represents vector quantity A. So what will happen if I multiply 2 into this vector quantity A? So what will happen is that the magnitude of this vector quantity A will be doubled. Okay, as we are multiplying by 2, the magnitude of the vector quantity will be twice as the magnitude it had previously, but the direction will remain same. So what will happen in this case is that if I multiply this by 2, then this quantity will double. So the new vector quantity will be like this. It will be the same direction, but the magnitude is double. Okay, so this is 2 into vector quantity A. Okay, so as you can see that I have parallelly shifted this, so the direction is same. So both these vectors have the same direction, but the magnitude of the second, this one, is twice of the magnitude of A. Okay, this has magnitude A, so this has magnitude twice of A, the magnitude, but the direction remains the same. Okay, but if I multiply this A with -2, if I multiply -2 into A, then the direction will be reversed. Okay, so the magnitude will become two times of this A, this quantity A, but the direction will be reversed. Like this will be the value of 2A. So this is -2A. Okay, so this vector is -2A. Simple. Only you have to for graphically representing the vector quantities, just you have to take the help of an arrow. Okay, only one arrow you have to draw, and twice of a means just you have to double the length of that arrow, and the length of the arrow just represents the magnitude, and the direction of the arrow represents the direction in which the vector quantity is pointing. Okay, simple concept, nothing great about it. So now we will learn about addition and subtraction of vectors. So what we had, so how we are going to add and subtract two vector quantities. Okay. Say if so, first we are going to learn about the graphical methods of adding and subtracting vector quantities. Okay. So this is graphical method of addition and subtraction of vector quantities. Okay, this is the graphical method. So say there is a vector quantity A like this. This is the vector quantity A. And there is another vector quantity B like this. Okay. So I want to add these two vector quantities, that is B and A. So what I will do is that I will parallelly shift this vector B. As I have already told you that by parallelly shifting a vector, the vector remains the same because the direction and magnitude remains the same. So the vector remains the same. So now I am going to parallelly shift this vector, and what I am going to do is that I am going to place the tail of B, that is this point, in the head of A. Okay, the tail of B in the head of A I am going to put. So after parallel shifting, B will be here. Okay, this is the quantity B. This is the same vector B. Now I am going to add, so adding A vector this here to B is same as adding like this, because I have just parallelly shifted it. Now suppose, say this point is X, this point is Y, and this point is Z. Okay. So what is the meaning of A vector? Suppose, let's say A vector is a displacement vector. So what a person did is that person went from the point X to the point Y. Okay. Then it went from point Y to point Z. That is the meaning of adding two vectors, vector A and vector B. Okay. So a person is going from X to Y. Let's say the vector is displacement. So first the person is going from X to Y, and from Y the person is going to Z. So going from X to Y and Y to Z is same as doing like this. Okay, sorry. So if I directly go from this one, okay, if I directly go from X to Z, then this it is same as going from X to Y and Y to Z. Okay, let me make it clear. Okay, so if I go from like this, assume it is straight. So by going from X to Y and Y to Z is same as going from X to Z. So this new vector, let's say C, is the sum of A vector and B vector. Okay. So if I go from, say like this and like this, then I can just go like this, then it will be same. So A vector plus B vector, this is the C vector. So as you can see, as you can see that these three vectors, that A, B and the sum C, that is A vector plus B vector, these three things make the sides of a triangle. Okay, see, A, B and C are the sides of a triangle. That is why what I did now is just like adding two vectors. I just joined the first x to z, that I did. So that whole process is known as triangle law of addition. Triangle law of vector addition. Okay? Okay, this is simple. So so what is the triangle law? So if I have to add a vector like this, say x vector, and another vector, say y vector. So how I will add? I will just draw a vector like this, and this will be z vector. So this z is the sum of x vector and y vector. Just I am going to just draw another vector like this. Okay. So z vector is equal to x vector plus y vector. This is simple because these three things are forming the three sides of a triangle. That is why the name is triangle law of vector addition. Simple. You can just imagine that if a person goes from this point to this point, then he goes from this point to this point. It is same as going from this point to this point. That is why the sum of x vector and y vector is z vector. Okay. As we have learned the triangle law of vector addition, there is another law of vector addition, that is parallelogram law of vector addition. Okay, this is just the same thing, just put in another way. The triangle law of vector addition, if we just twist and turn and just put it in another way, then that will become the parallelogram law of vector addition. Both the laws are same, means they give the same results. Okay, only two different names. Okay, just for your knowledge I will explain that. So what is the parallelogram law of vector addition? So if there is a vector, say A, in this direction, assume this line is straight, and if there is a vector B in this direction, okay, so what is the sum of this A and B? Okay, so you may solve this question without looking at how I am solving it. As I told you in the last, I explained you the triangle law of vector addition. So you may just pause the video and just add these two vectors, that is A and B. Okay. So how I am going to add these two vectors? I am going to shift. I will apply triangle law of vector addition. So I will shift this B vector parallelly, and I will bring it here. Okay. I'll shift it here. This is the B vector. And how I will now add this A vector and B vector? Just by using the triangle law. This is the sum. Okay, assume this line is straight. So this is the C vector. That is the addition of A vector and B vector. Here I have used the triangle law. So another way to think is that I have just shifted B vector to here to this point, and I have added A vector and B vector. What if I shift A vector also? If I shift both A vector and B vector, then what will happen? So if I shift A vector here, so it will become like this. Okay. So now the whole figure that you can see, let's say x, it is say x, y, z and z1. So this whole figure, this is a figure of a parallelogram. That x, y, z1, z. This is a parallelogram. Okay. So parallelogram is like this basically. It has two parallel sides. Like this side is parallel to this side, and this side is parallel to this side. So this is a parallelogram. So now we have formed a parallelogram in this case. Okay. So another thing that we have learned is that the the c vector is the diagonal of the parallelogram that we have formed right now. Okay, this x, y, z1, z, this parallelogram, c vector is the diagonal of that parallelogram. So what is the parallelogram of vector addition? So the parallelogram of vector addition is same thing. It is says that if there are two vectors like this, a vector and say b vector like this, here as you can see that the tails of both these vectors are at the same point. Okay, I have joined the tails of the vector A and vector B. So the sum of these two vectors, that is vector A and vector B, is the diagonal of a imaginary parallelogram that we are going to form. Okay, this is the value of C vector. How I have got this? I have just shifted B and I have brought it here. I have shifted A and brought it here, and C vector is just the diagonal of this imaginary parallelogram that I am forming. Okay, this is the parallelogram law of vector addition. Simple. Same as the concept is similar to the that of triangle law of vector addition, only a new name. You can apply any of these two laws whenever you are convenient with, and you can just add two vectors. This is parallelogram law of vector addition. So now we have learned about vector addition. So how we are going to perform vector subtraction? Okay. So if I say a vector minus b vector, so what is the meaning of this? If I say a vector minus b vector, this is equal to a vector plus minus of b vector. Okay. This thing we can write like this. A vector minus b vector is equal to a vector plus minus of b vector. So how can we graphically represent the thing? So if this is a vector, and say this is b vector, so we are going to add minus of b vector to a vector to get a vector minus b vector. So what is minus of b vector? This is same, minus of b vector means a vector which has same magnitude as b vector, and the direction is exactly opposite to the direction of b. That is the meaning of minus of b vector. Okay, so here it is the b vector and I am doing minus of b vector. So this is, assume that it is exactly opposite. Okay, and opposite direction, and the magnitude of is same, but it has exactly opposite direction. If this is uh, say c vector, so minus of c vector is just exactly opposite and the same magnitude. Okay, this is minus of c vector. So that I have tried to draw here. And now we have got a vector and minus of b vector. So just we are going to add them as in the triangle law. If someone goes from here to here, then here to here, so it is same as going from here to here. So this is the sum of a vector plus b vector. Okay, simple. So this is vector subtraction. So now we will solve a small question and then we will complete this class. So this is the question. The magnitude of displacement is, so this is, I have written here, this means that this is the magnitude of A vector. Okay, I have written A in bold as I told you that this represents a vector quantity. So the magnitude of displacement is 3 meter and displacement B is 4 meter, and uh, okay, here there is a mistake. One second. It is A vector plus B vector is equal to C vector. Okay, A vector plus B vector equal to C vector. Okay, it is not magnitude. We are not adding the magnitude. I have written that A vector plus B vector equal to C vector. Consider the various orientations of A vector and B vector. Okay, such that C has maximum possible magnitude, C has minimum possible magnitude. Okay, so C vector is formed by adding two vectors, that is A vector and B vector, and the magnitude of A vector is 3 meter, the magnitude of B vector is 4 meter. You are asked that you have to orient, means you have to take the directions of this A vector and B vector in different directions, and in which direction C has the maximum possible magnitude, and what is that magnitude also you have to tell. And by putting A vector and B vector in which direction, C has the minimum possible magnitude, and also you have to tell me the what is the magnitude. Okay. So hope you understood the question. So now you may pause the video and solve this question. Okay. So the answer is okay. So now we are asked that there are two vector quantities, say A and B, and the sum is say C, and the magnitude of A is 3 meter, magnitude of B is 4 meter, and we are asked that in which direction that we are going to put A vector and B vector such that C will have the maximum magnitude and minimum magnitude. So say that A vector is like this. I don't know what is A vector because I have only the magnitude 3 meter. Say it is in this direction and B vector is in this direction. The magnitude of A vector is 3 meter. Magnitude of B vector is 4 meter. So let's say this is the C vector. Okay, this is the C vector. So what will be the magnitude of this C vector? By seeing this diagram, we will think what will be the magnitude. You must have learnt in properties of triangles that sum of two sides of a triangle is always greater than the third side. That you must have learnt. Sum of two sides of triangle is always greater than third side. So, C, the magnitude of C vector, sum of two sides is always greater than third side. So, sum of two sides, that is 3 plus 4, 3 plus 4 is greater than the magnitude of C vector. That is what magnitude of C vector, say it is x. So these three are forming a triangle. So sum of two sides, that is 3 meter plus 4 meter, is greater than the third side, that is the magnitude of 3 meter C vector or x. Okay. So 3 plus 4 is greater than the magnitude of C vector. So 7 is greater than the magnitude of C vector. So if I keep A vector and B vector in this direction like this, then the C vector will always have a magnitude that is less than 7. Okay. So this way I can see from the triangle. Any way you put, say this is A vector, this is B vector. Sorry, it will be longer because it's 4 meter. So let me draw it again. A vector and say this one is B vector. Okay, so this is C vector like this. C vector. So let this one is given 3 meter magnitude. This one is given 4 meter. So the magnitude of this this length of this arrow, that is the magnitude of C vector, is obviously less than the sum of these two sides, that is 3 plus 4. This C vector is less than, the magnitude of C vector is less than 3 plus 4. So always, like if you keep these two vectors like this, then always the magnitude of C vector will be less than 7. So how I am going to orient these two vectors A and B so that I will get a number greater than 7. Okay, like this, if I am going to keep, anyway I am going to keep like in a triangular form, anyway I am going to keep these two vectors. If you say that if I keep vector A like this, vector B like this, then obviously I will use the parallelogram, and also I can use the triangle law also, the same thing. So I will just transpose this B vector here and B vector here, and again these two are forming the two sides of a triangle. Sorry. So okay, I'll do it again. So if it is A vector like this, B vector is like this, if I keep it, then I will just transpose this B vector here, and this will be the C vector. So again this B vector, here the B vector, C vector, A vector and C vector are forming the three sides of a triangle. So obviously here also the C will have magnitude less than 3 plus 4, that is 7. So any case it is having a value less than 7. So I am going to put it such a way that at least it will have a value equal to 7, or I don't know what. So how I am going to put these two vectors, that is A vector and B vector, let us see. So if I put A vector like this, A vector, and if I put B vector like this is B vector, then the sum of these two vectors, that is equal to C vector. It will be same. So here this is the sum. Okay, if one goes from, whenever you are asked to add the two vectors, just think that if one is standing here, let's say at point x, this point y, this point z, if one goes from x to y, and in same direction one goes 4 meter, that is y to z, then obviously it is same as going from x to z. So what is the value that one will go? Okay, so from here to here 3 meter, here to here 4 meter. So from x to z in the same direction, same straight line I am doing. So it will be 7 meter. So as you have seen that in every other case, the value of C is less than 7 meter. And in only this case, when the two vectors lie on the same line, in that case only, the magnitude of that third vector, that is C vector, is 7 meters. Okay, so the first question was, C has maximum possible magnitude. So it has maximum possible magnitude when the two vectors lie along the straight same line like this. Okay, then only C will have maximum possible magnitude, and that magnitude is 3 plus 4, that is 7. The second bit is C has minimum possible magnitude. Okay, for this thing you have to just uh, means reverse, means we have to subtract something like that. So for the second bit we will just proceed like the first bit. Okay, so if I say that C has minimum possible magnitude, then say this is a vector, and say this one is B vector. So I am going to put C vector such that it has minimum possible magnitude. So see that if I put B vector in this direction, B vector, and if I put say A vector in this direction. Then C vector will come in this direction, that is I am applying the parallelogram law. So this is the magnitude of C vector. What if I tilt A vector like a little bit? Say if I put B vector here, and if I say if I put A vector in this direction like this. Here you can see that the magnitude is coming a little bit less. Okay, so what I will do is that I will put B vector in this direction, A vector in this direction. So it is 4 meter, it is say 3 meter. So now the sum of these two, A vector and B vector, is 4 minus 3 because these are in two opposite direction and along the same line. Okay, so it will be 4 minus 3, that is 1 meter. So the answer of the last question is C has minimum possible magnitude. This is when both these vectors, that is A vector and B vector, are in opposite direction and along the same line. Okay. Also you can take parallel lines because the vector remains the same. So when they are in the same along the same line, say and in exactly opposite directions, then the magnitude C will have the minimum possible magnitude, and that will be equal to 4 meter minus 3 meter, that is 1 meter. Okay, hope you understood, and that was it for this class. Hope you like it, and please like, share, subscribe to my channel, and also press the bell icon to never miss an update from my channel.